Hari Om. We consider the rolling motion again. And here we are considering the motion of a body which is rolling on an inclined plane. And what is its acceleration? What is the equation for acceleration? So to find that, let us consider a body, a ring is now rolling down an inclined plane. As it is rolling down, there will be a frictional force acting which is along this direction, that be Fr. And this Fr will be making the body to roll down, and so that the center of mass will be going along this direction linearly, and the mass of the body applies a weight mg vertically down, and here I can resolve that mg into two components. One along this direction, that is mg cos phi, and here this will be mg sin phi is coming. Alright. Now, as this mg sin phi is making the body to roll down, and the friction supports it without slipping, and therefore the resultant force which is acting downward, resultant force acting along the incline will be equal to, let us say, m into a, where a is the resulting acceleration downward, which is equal to mg sin phi minus Fr, force of friction. Now, as we are considering the rotation and also translatory motion, we have to bring this Fr in terms of what we call the rotational motion. Now, from this figure, we can find that there will be a torque acting to rotate this one, and that torque acting on it, torque will be equal to torque will be equal to R cross Fr, where R is the radius of this one and Fr is the frictional force. So, force and perpendicular distance. This is the concept here. And therefore, as they are perpendicular to each other, you can say this is nothing but equal to R into Fr. Alright? And this R into Fr, I can take it in terms of moment of inertia of the body into angular acceleration alpha. This already you know. Alpha is the angular acceleration. Angular acceleration of the rotating body. And therefore, from this one, I can have Fr is equal to, Fr will be therefore equal to I into alpha divided by R. Okay? I into alpha divided by R. But what is this I? For that, we have taken the I as m k square into alpha by R. Now I bring this alpha in terms of linear acceleration, because we have got linear acceleration in here. So I can write this to be equal to mk square into a by r into r. because alpha can be taken as a by r, because you know that linear acceleration A equal to R alpha. One formula you study. And out of this I can take alpha equal to A by R. So R into R square it comes, and therefore I can write this to be equal to M into A into K square by R square. So this is what you are getting as what you call force of friction. So I brought that moment of inertia and rotational, what you call angular acceleration, everything into this, and I am getting the equation finally in terms of linear acceleration along with radius of gyration of the body. Now if I bring this into this equation, what we get? So steps understood. We have written for torque, and torque is equal to I into alpha, and from there Fr equal to, and moment of inertia in terms of what we call radius of gyration, and we are getting all these things up to that. Now I bring that Fr into this particular equation. Okay, what we are getting? Let us see. M into A therefore will be equal to mg sin theta minus m into A into K square by R square. So we are looking for acceleration A, therefore here also it is there. I can bring this together, and what I get is m into G into sin theta equal to, bring it over here, I get m into A into 1 plus K square by R square, bringing it over here. And therefore, just find, we can find that therefore acceleration A, linear acceleration A for the rolling body will be equal to m into G, sorry, m is not coming there because m and m will be cancelling. That, you see this one, this m and this m cancels, and therefore A equal to G sin theta, sorry, sin theta not, this is not theta, this is phi, and this is also phi. So sin phi divided by G sin phi divided by, what do you get? 1 plus K square by R square. So this is the equation for linear acceleration for the body which is rolling on an inclined plane. Okay, without slipping. So this case we understood. Now suppose that the body is sliding down. Suppose that the body is sliding down. When it slides down, you can find that there is no friction there. This friction will be 0, and therefore, in the case of sliding, we can get. So this is the equation for rolling case, and now I am taking sliding case. In the case of sliding, what I am getting is sliding motion, this part will be 0, and therefore acceleration A will be equal to G sin theta, G sin phi. So this is the case of what you call sliding motion, okay, and acceleration is equal to G sin phi. In that case, the friction is 0. Now when you compare that sliding acceleration and rolling acceleration, you can find that the rolling acceleration is getting small compared to what you see in the sliding. So sliding motion is faster than what you call rolling motion. This is already we have seen the case of energies. Now also we are getting in terms of acceleration. The same thing again, proven. So these are the very important facts relating to what you call the rolling motion, a combined motion, that is rotation plus translation, and this part will be asked for the entrance exams. So be very thorough with these things.